All right, third test is also going to cover the reproductive tract. And again, when you think of the reproductive tract, you're going to have to separate between the male and female. We've probably talked about some of this already, but I'm just going to give you kind of a quick overview of both of the tracts. Just remember that the first day of class, I said the big significance is that the male, or using the symbol versus the female, and using the female symbol, is that the male has a closed reproductive tract and the female has an open reproductive tract. So therefore, let's just look first of all at the female. We'll start out with a quick overview of the female reproductive tract. This you're always going to see on an exam, a drawing very similar to this. It actually does look very similar to the way it looks like in the human body, except when the human body is deceased or dead as a cadaver, it actually loses all of its form and it doesn't really look as nice as you really would like it to. And so if I'm looking at what I would call a gross picture of the female reproductive tract, I want to label certain structures on it. And so I'm going to do something like this. I'm going to say this is my ovary. This is going to be a fimbria. That actually tells you why the female has an open reproductive tract, because that is an open into the peritoneum. So that's why a woman could develop peritonitis if she had an uncontrolled STD. Kind of think of the toxic shock syndrome cases of the 80s from tampons left in too long. This is going to be my fallopian tube. Or the oviduct. This is going to be my outer covering of the uterus, so that's going to be the perimetrium. Remember, that's going to be connective tissue. This is going to be the muscle layer, so that's my myometrium. You want to think of the myometrium because that's where you're going to get what's called a leiomyoma, or a woman that gets a fibroid uterus. So those are going to be muscle tumors. And then I'm going to have the inside lining of the uterus, which is going to have two layers to it. And so I'm just going to kind of draw them like this. And therefore, those two layers on a circle here are going to be the inner layer. When I'm saying inner, inside the uterus, that's going to be the functional endometrium. That means that's the part of the endometrium that you're going to lose in menses or menstruation. So it's going to rebuild itself theoretically every 28 days. The layer that is going to be the outer layer, outer mean outer towards the outer portion of the uterus, so that's your outer layer, and that's going to be the basal layer. And that basal layer is the one that's going to rebuild a new functional layer every 28 days. So this is going to be called, the proper term for the inner layer is the stratum functional. It's just the word functional with an E on the end that they still use to this day. And the layer on the inside is going to be called the stratum basal. So it's just the word basal, but with an E at the end. So again, the stratum functional is the layer that's going to be lost in menses or theoretically every 28 days. It's going to be rebuilt by the stratum basal or the basal layer that's going to be highly vascular. So the significance of this basal layer, it's highly vascular. I'll get to the significance of that in a minute, except I want to come back up here to this drawing, and I can see that there's a dome portion here and a dome portion here, and that's going to be called a fornix of the uterus. And so therefore, just a quick overview again. If we're looking at the female uterus, we know it's going to have the body of the uterus. So this is the body or the inside. It's going to have an outer layer of connective tissue called the perimetrium. It's going to have a muscle layer that's going to be called the myometrium. And it's going to have an inner layer called the endometrium. It's that endometrium that's going to be significant for the pathology of endometriosis, which really means endometrial tissue outside of the uterus. Remember that the endometrium is going to have an inner layer, meaning towards the inside of the uterus, which is the functional endometrium. That's what I'm going to lose in menses, called the stratum functionale. It's going to have an outer meaning to the outside or periphery of the uterus, which is called the basal layer or the stratum basal, highly vascular, and that's the one that's going to be lost. That's the one that's going to rebuild the functional layer from menses. Now, the next thing we want to understand is that we have to somehow have fertilization. So whether we're talking of male or female, let's just look to the male reproductive for a moment here. Remember that, first of all, if you look at the male side, the male's going to have a scrotum, and inside the scrotum is going to be the testicle, plural, the testes. So we're going to tie both of these together literally, and so here's the scrotum. Sitting inside the scrotum, and it literally can be drawn, as I say, like a soccer ball. And so here is the testicle that's sitting inside of the scrotum. So this is the scrotum. Remember, the scrotum is going to be smooth muscle. Sometimes you'll see that called the dartos muscle. But it's involuntary. So this is the testicle. The testicle is going to divide it into lobules. So each one of these is called a testicular lobule. And each of the lobules is going to contain two things. It's going to contain seminiferous tubules, and those are going to produce the sperm, and it's going to contain interstitial cells, and those are going to produce testosterone. So supplying that, of course, is going to be a blood vessel. So the blood vessels have a series of capillaries as it goes in. So this is the blood supply. Remember, blood supply means I'm going to have an arterial supply and a venous supply. Because the testicles and the sperm are very sensitive to temperature, I'm going to have to cool the blood down as it comes into the testicle. And as I cool the blood down, it's going to go through what's called the testicular radiator. And that's called the pampiniform plexus. So that's going to cool that blood down as it enters the testicle and prevent the sperm from dying. That's why, if you sit in a hot tub too much, if you're in really hot water too much, If you have very tight-fitting clothes in hot weather, it will literally cause your sperm count to go down or your sperm to literally die. Okay? So that's a significant thing. The second thing is, remember, that I have to get those sperm to get out of the body, but I've got to know something about the structure of the sperm. So we're just going to draw a very simple sperm. You're going to see this is exactly as you'll see a very more detail, but you'll see this basically on the exam, just like this. And you'll always see a structure like this, and we're going to say that this portion at the front, this darkened portion, is going to be called the acrosome. So this is nothing more than a drawing of a sperm. The acrosome then is going to be at the top of the front of the sperm, called the head. So that's the head of the sperm. This here represents mitochondria. Remember, mitochondria are the powerhouse of the cell. They're going to provide energy or for metabolism. So therefore, this portion of the sperm is going to be called the midpiece, or the metabolic portion. And then finally, the back portion here is the tail. Sperm have to swim in order to enter the uterus and then finally get into the tube so fertilization can occur. And so therefore, this acrosome, if I was to open it up and just look at the head of the sperm here, you'll see that if this was an egg over here, so here's an ovum or an egg. And if this is the sperm, so then when this sperm head bumped up against the egg itself, the acrosomal cap flips over to the side, and sitting behind it is going to be two things. There's going to be an enzyme, which is called hyaluronidase. And that's literally going to eat through the ovum, and then inside of there is going to be the chromosomes, sometimes called the chromatin. And that's going to, once that enzyme eats its way through, it's literally going to take those chromosomes to go inside of the ovum. Since the ovum has got 23 chromosomes, and behind this head, so if this head really looked like this, you're going to see that inside of here are 23 chromosomes. You're going to take the sperm, which is 23, is going to meet up with the ovum, which is going to be 23. And when fertilization occurs, it's going to produce a zygote, which is going to be 46 chromosomes. Remember, this is going to be the N number, or the haploid. This is going to be the N number, or the haploid. And this is going to be the 2N number, or the diploid. So again, to make this very, very simple for you to understand, if this again is the uterus, this opening right here is the external os. This opening here is the internal os. Remember, the sperm are going to enter through the external os, passing through this tube, which is the cervix, and enter to the body of the uterus. Once they get into the body of the uterus, that sperm has to literally, so here's a sperm, we're just going to use this as a diagram. It's going to pass through the external os into the cervix, pass through the internal os into the body, work its way into the tube. And remember, the tube is going to have these fimbria and the ovary down here. And so this ovary is going to expel an ovum. So sitting right here in the proximal 1/3 of the tube is going to be this ovum. When this sperm reaches that ovum and fertilizes it, that's going to turn that into a zygote. So remember, it was the sperm plus the ovum is going to lead to a zygote. And it's going to remain as a zygote for about 2 weeks. And that 2-week period is going to be called the pre-embryonic period. And then once that 2 weeks passes, it's now going to, so fertilization, so sperm in the ovum, this is fertilization, producing a zygote. The zygote then is going to work its way down to implant somewhere. So when it goes to implant during this pre-embryonic period, you can either have a normal implant, and that's going to be in the uterus, or you can have a ectopic implant. What are the two options of that? Well, one would be in the tube, so that would be a tubal pregnancy. That's going to more than likely cause a miscarriage. Or because it's an open system, that fertilization could end up coming somewhere out here in this opening of the peritoneum, and you'd have an abdominal pregnancy. But neither of those are basically viable. So you want to realize that fertilization is going to occur normally inside the proximal 1/3 of the fallopian tube. So now we're just going to go through the stages just very quickly so you understand that. So remember, we're going to have, first of all, we're going to have a sperm. The sperm is going to meet up with an ovum. When the two of them go together, it's going to cause fertilization. Fertilization is going to lead to a structure called the zygote. It's going to remain a zygote until it's going to implant. When it implants, it's going to turn into what's called a blastocyst. Once that 2 weeks passes and it implants as a blastocyst, it's going to then turn into an embryo. It's going to stay an embryo until the 8th week. At the 8th week, it's going to turn into a fetus, and it's going to stay as a fetus until a normal delivery. And we're going to say a normal delivery is approximately going to be 40 weeks. Okay? So again, you want to understand the structure of the sperm. You want to understand the structure of the uterus. You want to understand that the structure of the testicle. And you, again, want to think about the hormones that are significant. And so the thing that I want to stress here is the significance, just remembering that Chapter 9 covered these hormones, but just think of a very simple example of the woman in menopause. We talked about this when we did the endocrine system. Just think of a woman in menopause. What we're going to do is we're just going to draw, here's this woman's head, here's her body, here's her legs, And of course, sitting up here is going to be the H for the hypothalamus. This is going to be that portal system. This is going to be the AP, or the anterior pituitary, or the adenohypophysis, and this is the ovary sitting here. Remember, the ovary is going to be the TO, or the target organ. If this one was in menopause, just think that menopause is going to present, we'll say, as a woman that's 45 years of age, and she says she has hot flashes, and she has mood swings, and she has osteopenia or osteoporosis, thinning bones. That's because her ovaries are no longer able to produce enough estrogen. So remember, the ovary produces estrogen. So a woman in menopause says, well, let's see. We know that there's a blood supply going from here to here, and then there's a blood supply going from here to here in the systemic circuit. So the hypothalamus is releasing something called GnRH, gonadotrophic releasing hormone. That's going to pass through the portal system between the hypothalamus and the anterior pituitary. Anterior pituitary is going to produce FSH, follicle stimulating hormone. That's going to pass through the entire body except to the only place that it has a receptor, which is the ovary, and therefore the ovary is what's coming out of it is estrogen. Remember that this woman is diagnosed as having menopause because she has basically low estrogen. So all of this can be described as a person that really has low estrogen output. What does the body do as a result? Well, as a result of that, because of the feedback loop, it's going to cause an increase in gonadotrophic. So remember, estrogen is going to be down, so decreased E. That's going to pass through the bloodstream. It's going to go to the hypothalamus, and the hypothalamus is going to say, I'm going to increase GnRH, gonadotrophic releasing hormone. That's going to pass through the hypothalamo-pituitary portal system to the anterior pituitary. The anterior pituitary is going to increase FSH, follicle stimulating hormone. The follicle stimulating hormone is going to go to the ovary, the target organ. But the problem is the ovary is either too old or no longer has any more ability to produce more estrogen. So I have two options that are going to happen. Either I'm going to have hypertrophy, which means, remember, that's an increase in cell size, but not number, or I'm going to have hyperplasia, which is an increase in cell number, but not size. That's the one that scares me because that can lead to cancer. So how are we going to get this woman under control? The only way to really do it is they've tried all kind of different uses of, I would call it phytohormones to do it, and none of them really work. But we just add exogenous estrogen. And we could do that using, for example, Premarin or birth control pills. And together, those are called HRT, hormone replacement therapy. What does that do? Well, when I add HRT, so if you add, so now we're just going to make a simple last linear diagram. Remember, if we're now going to have this woman in menopause, how do we treat it? Well, we're going to add HRT, hormone replacement therapy. What's that going to do? Well, if we just make this real simple diagram without putting all the labels in it again. When I add the HRT, remember this is a feedback loop. Remember the ovary had decreased estrogen, but now I'm adding HRT into that loop. When I add the HRT, hormone replacement therapy, it's going to cause the hypothalamus to decrease the GnRH output. So I'm no longer be bombarding the anterior pituitary, so it's going to decrease the FSH output. And because of that, it's going to stop the ovary from undergoing more hypertrophy or hyperplasia, and hopefully the HRT will take care of some of the osteopenia, osteoporosis, some of the hot flashes, and some of the mood swings. So that's what I would call a big example or an overall example of how we're going to look at the reproductive system.